Right, hello there. This video covers how to calculate the formula of a hydrated ionic compound. Now, if you want to have a go at the calculations, it would be really helpful if you had a calculator and, of course, a periodic table with you. So I'm going to cover with you what a hydrated ionic compound is and what an anhydrous ionic compound is. Then I'll show you how to calculate the number of moles of water in a hydrated ionic compound. Now, anhydrous ionic compounds don't contain water. So, for example, anhydrous sodium sulfate would be Na2SO4, whereas hydrated sodium sulfate contains water, so 0.10 H2O. Now, if you were to calculate the MR of this, you'd calculate the MR of sodium sulfate, and then you'd add 10 times the MR of water, and what you'd get is this. And if you put all that in your calculator, you'll get an MR of 322. Another example would be magnesium sulfate. The anhydrous ionic compound is MgSO4, whereas the hydrated ionic compound is 0.7 H2O. Now, there are quite a few calculations that come up that ask you to work out the formula, so i.e. the number of moles of water in the hydrated ionic compound. Let me show you how to do that now. So this is an experiment you could do in class. So you could get a crucible. This is a crucible, which is a piece of apparatus that allows you to heat something really, really strongly. And you could get a clay triangle and mount this on a tripod. And what you could do is you could fill this with hydrated copper sulfate, for example. Now, when you heat hydrated copper sulfate, what happens is the mass will go down as water vapour is given off. And this is an example of some results that you might have. So you've got the mass of your crucible with hydrated copper sulfate heated up, and the mass keeps going down. Now you will notice that the last two results are the same, and if we weigh to constant mass, then we can assume that all the water's been given off. Now what we need to do is work out the mass of anhydrous copper sulfate and the mass of water, and then we can work out the formula. Now, this mass here, 16.96, is the mass of the crucible plus anhydrous copper sulfate. And if we get that and subtract the mass of the crucible, we've got the mass of anhydrous copper sulfate. Let me do that now. So the mass of anhydrous copper sulfate is 1.71 grams. Now, to work out the mass of water, we need the mass of the crucible plus hydrated copper sulfate, 17.92, and we need to subtract 16.96. That'll give us the mass of water. Bear with me. So there we go. If we transfer the mass of the anhydrous copper sulfate and the mass of water to a table, we can easily work out the formula of hydrated copper sulfate. I'll do that for you now. Okay, so I've got my masses on a table there, and this really helps me follow the method of how to do this. Now, we need to convert mass to moles. Now, moles is mass divided by MR. So for copper sulfate, it's 1.71 divided by the MR of anhydrous copper sulfate, which is 159.5. Similarly for water, 0.96 divided by the MR for water, which is 18. Now let me work that out. So we've got the numbers of moles here, and if we divide through by the smallest, so 0.0107 divided by itself, of course, is equal to 1. 0.0533 divided by 0.0107. Now let me put that in my calculator. So divided by 0.0107, and I get 4.98. Now we've got to have a whole number, so that is nearly 5, and I'm quite happy to round that up. So the formula is CuSO4 0.5 H2O. And that's what we've worked out. Let's have a look at another example then. So 5.00 grams of hydrated aluminium sulfate was heated to dryness. So the mass of the dry salt, so the anhydrous salt, was 2.568 grams. So therefore, to work out the mass of water, we need to get 5.00 and we need to subtract 2.568. Okay, let's do that now. So we've got the masses on our table. What we've got to do now is work out the number of moles. So moles is mass divided by MR. So let me just do that. So we've got the numbers of moles here. If we divide through by the smallest, so 0.00751 divided by itself, okay, is obviously 1. And 0.135 divided by 0.00751. Let me pop that on my calculator and work that out. So 0.135 divided by 0.00751, and we get 17.97. Okay, we can round that up to 18. So our formula is Al2 SO4 3.18 H2O. So that's something you could be required to do in your exam. Okay, so that's calculating the formula of a hydrated ionic compound, hopefully made simple. Thanks for watching.